of the conditional probability, conditional mean, and conditional variance. Okay, so to refresh your mind, let us do the ordinary mean first, okay, the mean here. So you know this is going to be 0 times 1/4 plus 1 times 1/2 plus 2 times 1/4, because it is xi times pxi, right? So xi times pxi, xi times pxi, xi times pxi. Okay, questions? And now we are going to deal with conditional mean, okay? And here, because x has 3 possible values, but y has 2 possible values here, okay? So we have here expectation of x given y equal to summation xi times px given y. But we know there are 2 possible values, right? So let us deal with this first. Pxy given y equal to 1, okay? And so you know it is going to be summation xi times px given y equals to 1, okay? And then here it is a conditional probability, right? It is going to be summation xi times p of y equal to 1. So this is the denominator, okay? This is the denominator, and here it is the numerator. So actually you have 3, right? You have py equals 1, px equals 0, y equals 1. So here is going to be px equals 0, right? Okay, you have x1, x2, x3, right? I'm sorry, this should be the first xi. What is this? The first xi is equal to 0, right? What about the second xi? It is equal to 1. And times py equals 1 and px equals 1, y equals 1, right? Okay, any questions? And what about the third one? 2 times py equals 1, px equals 2, y equals 1. Okay, any questions? Questions? No. Okay, and what is this probability? This is a conditional probability, right? That is equal to 1/4 divided by 1/2, right? So that is equal to 1/2. Okay, questions? Any questions here? What about the second one? Okay, it is 1/2 divided by, 1/4, okay, 1/4 divided by 1/2, right? So that is also 1/2, right? What about the third one? 0 divided by 1/2. So what is this equal to? 0, right? So then it is equal to 1/2. Okay? Any questions? So the same thing when you are dealing with variance. Okay, when you are dealing with variance, it will be the same thing. And now let us try. So this is the first case. X, expectation of x given y equals 1. Okay, let us try the second one. The second one is expectation of x given y equals 2, right? Okay, y equals 2. Okay, so the first part, it is xi, right? 0, 1, 2. It doesn't change. Okay, 0, 1, 2. What about the second one? It will be y P of y equals 2, and P x equals 0, y equals 2. The same thing here, P y equals 2, and P x equals 1, y equals 2. And here, P y equals 2, P x equals 2, y equals 2. Questions? So, up to this point, you should realize that as a matter of fact, statistics is quite simple. I mean, up to this point, it is quite simple. As long as you remember the definition, okay, of probability, okay, conditional probability, Bayes theorem, etc., and plug in the formula, okay, conditional mean, conditional variance, okay, you just remember the definition, okay, and then plug in the numbers. That's it. Okay. Okay, what about the first one? What is the probability here? So the girl behind the red t-shirt. So what is this? What is this part? Excuse me? 0, right? Because the numerator is 0 divided by 1/2. So what is that? 0, okay? Okay, what about the second one? Still you. 1/2, okay. Because it's 1/4 divided by 1/2, so that is equal to 1/2. Okay, what about the third one? 1/2, the same thing, okay? So then, that is equal to 1.5, right? 1.5, okay. So, for conditional mean, any questions so far? And of course, we need to deal with conditional variance, right? I don't want to show you again, but you know, it is the same thing. The only difference is we are talking about variance of x, then it is summation xi minus mu x times square pxi, right? And here, v of x given y, right? That is summation xi minus mu x squared times px given y. The only difference is probability. Here you use probability. Here you use conditional probability. Okay? Questions? Okay, then let us get to covariance. Okay? Sounds good. Okay. So this is Vx, right? Vx given y. Okay. Surprise. Okay, so we will wait for a few seconds, minutes. The only difference is here, okay? The only difference is here. Okay, let us move on. We want to talk about covariance. So what's the reason we use covariance? Because we want to know. Oftentimes, we are not only dealing with one variable, we are dealing with more than one. And generally, it will be two. So we want to know the relationship between two variables. Okay, so that is, if we want to know the relationship between x and y, we use what? We use covariance. Covariance is equal to expectation of x minus mu x and y minus mu y. So as a matter of fact, x minus mu x, y minus mu y, this is a line, okay? And this is also a line. So when you are dealing with covariance, you are dealing with linear relationship, okay? Okay, can I erase this part now? Yes or no? Okay, good. Thanks. So basically, you are dealing with this, okay? X and Y, okay? And then here mu X, okay, and mu Y. So basically, you have this kind of relationship. So if this thing, okay, if covariance XY is positive, okay, what does that mean? That means they are positively related. Okay, what means positively related? That means these two variables, they move in the same direction. Okay, so when we say two variables, they are positively related, that means they move in the same direction. So for example, price goes up. If price goes up, what about quantity supply? Quantity supply will go up. Okay, so let me put down this. If price go up, then quantity of supply will go up. If price goes down, quantity of supply will go down. So because when price goes up, the company can earn more, right? They can make more money, so they're going to supply more. Okay, they're going to offer more. On the opposite, suppose the price goes down, right? If price goes down, what happens? The firms will supply less, right? They will supply less. So they move in the same direction. When price goes up, quantity supply goes up. When price goes down, quantity supply goes down. We say these two variables, they are positively related. Okay? What about negatively related? So price goes up, quantity demanded will go down. Price goes down, quantity demanded will go up. Because if price goes down, it becomes cheaper, right? It becomes cheaper, then consumers will buy more, right? It becomes cheaper, consumer will buy more. It becomes more expensive, consumers will buy less. Okay? So these price and quantity, okay, in terms of demand, it moves in the opposite direction. So we say price and quantity demanded are negatively related, okay, because they move in different direction. One goes up, the other goes down. One goes down, the other goes up. And here it is positively related. Okay, one goes up, the other goes up. One goes down, the other goes down too. Okay, questions? And so we want to do the same thing again. We want to simplify it. Okay, so we have expectation xy minus mu x times y minus x times mu y and plus mu x mu y. Okay? Any question? We just expand. Okay, expand this form. X, y, x, mu x, y, and then x, mu y, and plus mu x, mu y. Okay, questions? Okay. Then it's going to be expectation xy minus, okay, expectation mu x times y minus expectation x times mu y plus expectation mu x mu y. Okay? Any questions? So then you have expectation of xy minus, here mu x is a constant, right? So we can move this out. Mu x times expectation y minus mu y expectation x plus mu x mu y, right? Because these are all constants, okay? Mu x constant, mu y constant. And what is this? This is actually mu y, right? Here it is actually mu x. So you have minus mu x mu y minus mu x mu y plus mu x mu y. So that is equal to expectation xy minus mu x mu y. So this is covariance. Okay, so this is covariance. Okay, questions? Any questions? Now we want to get to this part. We want to deal with this. Okay, so we just mentioned W. If W is equal to AX plus minus BY, right? So expectation of W will be equal to A mu X plus minus B mu Y. Okay, that is what we talked about before, right? Then we want to try to find out what is VW. Okay, what is VW? Okay, so VW is VAX plus minus BY. Okay, any questions so far? Questions? Perhaps we use, let me see, perhaps let's use plus first. Okay, let us use plus first. Okay. And then we're going to deal with the minus part, okay? Okay, so then what is this equal to? Can I erase here? Yes or no? Yes, okay, good, thanks. I forgot to finish this. Okay, so when X and Y positive, then X and Y, they are positively related. Okay, positively related. Okay, when it is less than 0, negatively related. When it is equal to 0, does that mean they are independent? No. They are only independent in the linear relationship, okay? So if it is equal to 0, covariance equal to 0, it only means that they are not they are independent in the linear part, okay, in terms of linear relationship. It doesn't mean they are independent in the other way. But if X and Y are independent, okay, if X and Y are independent, covariance must be equal to 0. Okay? So when covariance is equal to 0, it doesn't necessarily mean X and Y are independent. But if they are independent, it must be 0. Okay? It must be equal to 0. Okay. And now I'm just trying to remind you what is the variance of X. Variance of X is equal to summation xi minus mu x squared times p xi, right? And that is equal to expectation x minus mu x squared. Okay? Any questions? Okay, but now we are talking about VW, right? We are talking about VW. So what is this equal to? It must be equal to expectation of AX plus BY minus A mu X plus B mu Y squared. Okay, because Vx, variance of X, is equal to expectation X minus mu X squared, right? Okay, so here you are going to talk about W. So here it is W, this should be W, right? So W is AX plus BY, right? Okay, so it should be EW minus mu W squared, okay? So then it is here, right? And EW, what is W? W is AX plus BY, okay? And what is mu W? Mu W is equal to A mu X plus B mu Y, okay? So it is here. So when you do this kind of exercise, okay, you just compare what is going on there. Variance of X okay, variance of W, the same thing, okay. You apply the same formula. Just make sure that you plug in the right number. So in this case, W, okay, is equal to AX plus BY, okay. And then mu W, okay, mu W is equal to A mu X plus B mu Y. Okay, any questions to this point? Okay, let us try expectation of A X minus mu X, okay, plus B Y minus mu Y. Any question? So we have AX, A mu X, okay, we get A out, we get A times A X minus mu X, right? We have BY, B mu Y, so we have B out and Y minus mu Y. Questions? Okay, so what is this? So we have expectation A square X minus mu X square plus, okay, 2AB X minus mu X and Y minus mu Y, and plus B square Y minus mu Y square. Okay, any questions to this point? Any questions to this point? Okay, so let's try one more. Let us move it here. Okay, so then we have expectation A square X minus mu X square plus expectation 2AB X minus mu X Y minus mu Y, and then plus expectation B square Y minus mu Y square. Okay? Any questions so far? Okay. The third lady there. Okay, can you tell me what is this equal to? What is this part? What is this equal to? We can get A square out, right? A square expectation X minus mu X square. The same thing, we can get 2AB out, right? 2AB expectation X minus mu X Y minus mu Y. Okay, and plus B square expectation Y minus mu Y square. Okay, can you tell me what is this part? What is this equal to? What is this? What is this? The gentleman there. What is this equal to? Expectation X minus mu X squared. You know, you need to study hard. What is this equal to? Mr. Zheng, what should be this equal to? Vx, right? So that is A square Vx, right? Okay, what about this part? Okay, the gentleman again. Give you one more chance. What is this? We just talked about it. What is this? This is covariance, right? Covariance. 2AB covariance XY. Okay, then what about here? B square Vy. Okay? So then what does that mean? That means if W is equal to AX plus BY, then VW is equal to A square VX plus B square Vy plus 2AB covariance XY. Okay? So if W is AX is equal to AX plus BY, then VW must be equal to A square VX plus B square Vy plus 2AB covariance XY. And we just mentioned, right, we say if XY are independent, what happened here? If X and Y are independent, what happened here? The gentleman in blue t-shirt, if X and Y are independent, what happened to this part? It is equal to 0, right? Because it is gone. So if they are independent, then you have simply here. If they are not independent, it will be here. Okay, but originally what do we put? We put plus minus, right? And plus minus. Okay? So you are required to verify, okay, yourself. If W is AX plus minus BY, then it's going to be A square VX plus B square VY plus minus 2AB covariance XY. Okay, so this is something that you have to do on your own. Okay? So next class, okay, next week, I'm going to get someone up here to show this is the case. Okay? So I already showed you VW, okay, when W is equal to AX plus BY, okay, then you get VW equals A square VX plus B square Vy and plus 2AB covariance XY. So next week I'm going to get someone to show me that if it is minus, here it is minus. Okay? Questions? Any questions? Wow, time flies by. Okay, let us see what more we're going to show. I think we're going to take off early today. Okay, so next week we're going to show you the next part. Okay, good.